Hello, everybody, and welcome to the Automation Village Breakout stream for June 18th. I'm your host, Dave Spencer, and today we're going to have 3 different presentations coming to you in this stream, but we're also going to have a few other streams. If you want, you can check out. So right now you're watching the design, operations, and planning stream, but we also have a water wastewater stream and a digital connectivity stream. And if you want, you can kind of jump between streams as the day goes on and jump back and forth to see different presentations at different times. Also, please note that we are recording the streams today. So if you had a conflict with 2 things, then check back with us in a little bit. It usually takes us a few weeks to get these online, but check back with us and we will be posting these so you can see exactly what you needed. So first up today, we're going to have Christelle Bruneau from FLOWatch. She's going to be talking about modern data management software and hopefully making it a little bit easier for people who might be interested in it, but be looking for a little bit more information to kind of ease that transition. In the other 2 streams, in the water stream, we'll have Phoenix Contact talking about secure communications. And also on the digital connectivity stream, we'll have Brass, who will be talking about different IT topics, which are more designed for people who are in a factory environment. So let's get going with our topic for today in the design, operations, and planning stream. So up now, we're going to have Christelle Bruneau. And Christelle, do I have you online here?
I am online. Can you hear me?
Yeah, I can hear you well. How are you doing today?
I'm very good, Dave. How are you?
Cool. I'm doing very well. And where are you coming to us from today?
I am just outside of Philadelphia in New Jersey.
Right, cool. So, and you're going to be talking today about embracing modern data management software, correct?
That is correct.
Great. So for the people who are coming on for the stream for the first time, or if you haven't been to one of our previous Automation Village breakout sessions, then each presentation today is going to be 40 minutes. And like I say, in this stream, we'll have 3 presentations that are kind of back to back. So presentation starts in a few minutes here, then we'll go for about 40 minutes, and then we'll have a 10-minute Q&A session at the end. And in order to participate in that Q&A session, you're just going to click on the little Q&A button in the Zoom console, and you'll be able to enter your question there. You can enter the question anytime through the stream, and those questions will get sort of captured in order. And then during the Q&A session, we'll go through those. If you have a follow-up question or if you think of something else, then you can put it in during the Q&A stream as well. And we'll just see those coming up. And like I say, we'll plan to do that for about 10 minutes, but we do have a 10-minute break after that. So if the questions go a little bit longer, then we'll be able to cover those if we need to right up until the top of the hour when we'll be carrying on with the next one. So like I say, it's a 40-minute presentation, 10-minute Q&A, 10-minute break, and then repeat and repeat. So Christelle, if you want, feel free to grab the screen share there.
So yeah, thanks for having me again. I provided this a quick presentation last week on embracing modern data management for water and wastewater systems. Basically, this, for this session, I'm going to provide a refresher on that, but also expand on some key points that might be helpful, provide a little bit more depth for everybody, and then we can tackle the questions and answers after. So just to give you a little background about who we are, FLOWatch. We're a software firm and we're specialized in data management solutions for the water and wastewater industry, including the industrial wastewater industry as well. Our team is very experienced in software development, but we also all have backgrounds in the water operations and engineering field. The chief architect actually of the platform has a PhD in water reuse, and he also worked in operations. And then he migrated into doing software programming. So he's very broad skill set and incredibly intelligent. So this is how he came up with the design of the software. And then myself, I have like almost 20 years in a whole span of different companies, but private water company. I also worked for GE for industrial water treatment, and then engineering as well. So I'm very aware of all the different layers that tackle the water and wastewater spectrum. We have a really good partnership with a Texas SCADA integrator. And so we've created a distributor arrangement with them for specifically in Texas track control. And we've found a lot of success because they do a lot of work on the SCADA side. We have a nice partnership that's very fluid, and we can go back and forth on handling how to manage the overarching data management solution for a client. So our key product is a web-based and cloud-based platform that aggregates all kinds of information, any kind of plant information, all into one location. And then from there, you can slice and dice that information and do reporting and analytics, and also manage plant activities. At this point, we have hundreds of plants that are using FLOWatch online today. And these clients range from like municipal plants, private water companies, and then also industrial. Like we have an oil and gas company that does a lot of reporting to their state. So it's really not just for water and wastewater utilities like municipal. It can span all different kinds of types of clients in this field. So before I get into the weeds of our approach with how we design FLOWatch, some of the things that we noted in this sector, based on our experience working in this industry, is just what kind of challenges the operators are facing today out in the field, and the supervisors, and pulling information together. So from what we understood and have seen, a lot of operators have data sources in all different locations that they're pulling together, and they're very heavy paper-based. You have plant operators walking around with clipboards, writing their notes down, and logbooks, and then also, even I've seen people walk in with sticky notes with a totalizer value, and you'd imagine some of that information gets lost. It's a messy situation. Also, there's a lot of increasing regulatory requirements, as we evolve. There's going to be more things to be tracked for the states, and at a federal level. Also, because of all of this information being scattered, there's a lack of communication amongst the group, and it's not intentional. It's just how they've always done their work every day. Also, there's aging infrastructure is a big issue. There's more of a reactive approach to managing that. Pump goes down, now everybody's frantic. They're trying to get, all the information on what vendor they need to call to get that fixed. So there's a lot of, inefficiencies there. Also, the states are also requesting more transparency around what's happening at the plant. They come in and they do inspections, they check your logbooks. So that's, everybody's frantic to make sure they don't get violations. And also, as operators, especially in water and wastewater, are retiring or, going to different plants, it's hard to retain all that operational knowledge that they have. And of course, the big nugget is the budget. They don't have big budgets necessarily to, manage all these big projects that suddenly come about when things break, or they have to do plant upgrades. So as I mentioned, scattered data is all over the plant. You've got sources that are coming in from SCADA. So people have to log in and look at their SCADA, or, you've got lab data coming in. Some, depending on the level of, or the size of the plant, they may have a laboratory information management system, or they might just farm out the work out to a third party that's, doing all their lab analyses, and then they get sent back, and then they have to figure out when and how to put that all together for their regulatory information that gets sent to the state. They're using field instruments that always have to be calibrated. You've got GIS information for some plants. assets and maintenance just tracked in logbooks. I've seen, you know, a laundry list of assets, like just sitting in, you know, a big giant binder and not even in Excel. So also work orders are all done through paper and billing as well. So as I mentioned, heavy on the paper use, and also using Excel, which is also, it's great, but there's version control issues. So, you know, that causes a problem with making sure you're up to date with which Excel version you're looking at. There's increasing regulatory pressure, as I mentioned. You know, it takes a lot of time to gather all that information that's been collected on paper or on Excel out in the field, and that supervisor has to spend a lot of time to organize and review all that before he puts it or she puts it into any type of you know, DMR or a monthly operating report that goes to the state. And of course, with that comes a lot of you know, human error. It's not intentional, but you know, someone's writing something down, it's hard to read it. There's going to be an error somewhere along the way. And then there's more pressure as well with developing asset and maintenance plans. I've seen some states are starting to put together guidelines to get them to start pushing to put together these asset management plans. And in some cases, they've taken it further where they actually have specific reports they require. So a little background on the FLOWatch platform. After we collected all this kind of information of what's going on with operational processes, we decided to build a platform that was very focused on the plant operator. Essentially, you know, our strategy was to build a system that was very configurable or quickly configurable for any type of plant from the ground up. So the key to our I feel as though, well, our whole team feels as though that the key to software adoption, especially in our industry, is to make sure it's very user-friendly. Because if a plant operator or user of the system doesn't like it or doesn't want to use it or isn't putting in the proper data, the output reports for management is pretty much useless. So we wanted to build a system that was, like I said, easy to use, but also scalable. We want it to be so that you could easily configure it to the uniqueness of a plant. Within FLOWatch, we built it so that it was easy to add in any new regulatory parameters that you want to track, as plants are always, there are some plants out there that need upgrades, and as they do the upgrades, they change on what they're tracking at certain locations. So we wanted our system to be very moldable to the plant at any point in time. And we also obviously wanted to have an end goal of making sure that we're bringing efficiencies to the plant operations by using this type of software. Obviously get rid of pen and paper and spend less time preparing all these reports. And of course, you know, our goal was to create a modern technology, and that was very easy to access through the web at any time, and also be able to use mobile devices through a mobile app to collect that information. So, you know, instead of all these handheld devices that you're using, now you can put a lot of that information straight into a platform that you have quick access to. So this is just a diagram of like a central, you know, of how we envisioned information coming in and how all into one centralized platform. So you've got plant operations, as I mentioned, process information, SCADA, and then you also have chemicals, energy usage. You can bring in information, like I mentioned, asset and maintenance. So all of that would roll up into FLOWatch. And from there, you have an interface where you can log in and view that information and generate your own reports. There's the capability to, you know, run your own, create your own dashboards, or do higher level, you know, operational intelligence. And also managing activities at the plants, having more quality control on what's being done. getting notified when there's an issue at the plant. So you're having a more proactive approach to figuring out what to do to fix the situation. So based on what I mentioned about our approach, we came up with certain features that we felt were critical to our platform. And we always say, our platform is never going to be 100%. It evolves based on information that you're getting from your clients and constant feedback and, adding new functionalities over time. So we want it to be a very flexible situation where you can just, we can add more to it and every client benefits. But essentially, we wanted it to have, since the operator was key, we wanted the data entry forms to be very simple. So, operators are creatures of habit when they're adopting a platform, and it's easiest to allow them to see a log sheet just the way they had it on paper before. So we have a way to create a custom log sheet view for them, but also if they are really comfortable with the actual look and feel of the paper they were using, we can digitize that and create a digital PDF and still use that information for the same reporting in the same reporting way. So either way, we have different ways that allow the operator to pick and choose how they want it to be set up for them. Also, we've got some built-in regulatory reports that we've designed for specific states that we've been working in. We can, if we're going into a new state, it's not that hard. A lot of these are very similar in the sense with what they require. But essentially, once those are built, they're built to be used for any client within that state. So you've got your MORs, like I mentioned, on the water side. You might have a surface water treatment plant. They're much more complex, these MORs. Also, on the wastewater, you've got DMRs. But essentially, these managers have the flexibility to also review these compliance reports, but also they can look at dashboards from a general oversight of how the plant's operating as well. Some of them like to have a bird's eye view of what's going on, what's the well output, all kinds. It's whatever they imagine they want to see for their plant. It's the platform we built was designed to easily integrate with other infrastructure. So like I mentioned, SCADA or a laboratory information management system. You can create your own validation rules to remove any issues with like fat fingering, any out of range data. So, you may have someone, you want to make sure they're not typing in less than 1 or more than 14 for pH, but also you may want to have an operating range where they get a notification if, it's outside of a certain range, like outside of 4 and 7 of, for pH, and at least they get an alert and then they can figure out what they're going to do. Maybe they still save the data and it's fine that way, or maybe there's something that they have to do. So we have all of that activity workflow element associated to how to operate a plant embedded into FLOWatch. And as I mentioned, there's a CMM, I'd like to say CMMS, like preventative maintenance module that we have that you can add in all your assets, your inventory, also your vendors that you're dealing with for those assets, and create your maintenance activities that you want your team to follow, work orders, etc. So all of that is incorporated into FLOWatch. We made it flexible. You don't have to, it's not a situation where you have to use all of it. You can just use it for compliance reporting, or you can use it just specifically for asset and maintenance. It's really dependent on what the needs are for the plant. And at a higher level, we decided to add in also a budget management module. We felt that this was critical just for further down the road if a client wants to manage their plant KPIs or have some financial metrics to review on how operations are going. It's a nice to have feature. And also you can manage some of your capital projects, what you're spending on those projects through this module. And as I've mentioned, we have the ability to create a list of vendors and tie those vendors to, you know, your assets and all kinds of work that you need to get done. So just, I thought I skipped a slide there. Hold on. Okay, so here is just a little bit more information on the web-based and mobile app aspect of FLOWatch. You can access FLOWatch through our web portal. Every client's given a URL, and from there they'll have a user login and a password, just like you're checking your email on Gmail or something the same way. And you log in through any type of browser, Chrome or whatever you have available to you. And you'll have a web portal that you can view FLOWatch and review your reports or log data or or see notifications. But we also have a mobile app as well. The mobile app covers iOS and Android phones. We're looking into the Windows side of it as well. But right now we have an iOS and Android mobile app version because those are the front runners with mobile apps these days. The key to mobile app is that when you have limited to no connectivity, you can still log your information out in the field. And it's offline on your device, but when you're back in a location that has connectivity, it syncs up back to our the database and pushes all the information to the database. So then it's all there regardless, whether it's offline or not. Versus the web, you actually have to have internet connectivity. And a little bit more of a deeper dive on SCADA side or LIMS or any system that you're trying to integrate with. Essentially, we have a two-step process. We have a mapping module within FLOWatch that all we need are the tag IDs for what you want to track. And then, so that's step one, get the tag IDs, insert them in. Now we know what the mapping rules are from pulling information from SCADA into FLOWatch. But also, the next step would be to figure out how often you want that data pushed. So we have a little program that we have the clients use that they install, in their, in their zone, and then that data just tells pushes data to our SFTP site, and from there it pulls the information into our platform. So it's a one-way push. We remain disconnected for security purposes from SCADA or any other infrastructure. So it was designed specifically for that way for security reasons. And we also have an API as well, which is a common, depending on who we're working with, they may also have an API, and so it allows the systems to be able to talk to each other. And this is just, this is an example of some compliance reports we can run in FLOWatch. We had built one for Pennsylvania. You're looking at, these are like the look and feel of exactly what the state wants. And then also we have, like I mentioned, you can run some trends and do your data analytics through FLOWatch. It's really whatever, managers are imagining to see that'll help them benefit them in running their system, a lot more smoothly. So this is just more of a trending type report that they can create. And then going to the asset and maintenance side, this is an example of a work order dashboard. They can see what's being done by user and the status of the work orders. We can build an asset inventory list. We can do a conditioning report. We can do a criticality report. There's a bunch of different reports that certain states have already started pulling together that they want to see. So this would be work order versus, the asset maintenance side. So just to kind of recap on everything I've been talking about, in terms of technical benefits, as I mentioned, we created a system that is going to allow the users to quickly have access to information right away. Obviously everything is near real time because it's based on data coming in. But essentially, if you're getting SCADA data streaming in, you may have 15-minute intervals or whatever the client's interested in. But as they log in, they can go in and see all the information coming in from SCADA, the information that is coming in from the log sheets, and their mobile apps. And then from there, they can just run their reports with a click of a button. Also, the way we configured or designed FLOWatch, we made it, like I mentioned, it's supposed to be easily configurable. So, you're looking at a much shorter go live timeline. We have a specific process we have in place when we go through the implementation phases when we bring on a new client, and we can do things in just a matter of a few months, depending on obviously the size of the project, what they want, what the requirements are. But essentially, like, it's, you set up the plant, you set up the parameters they're tracking, you work on the SCADA integration piece, you do some training. It's a very fluid back and forth between between us and the client. And the key also to, these type of software solutions is that, you want to make it so that there's lower infrastructure costs. They don't have to go out and buy, since it's cloud-based and web-based and all that, we're managing the servers for all the backups. So the client doesn't have to go and figure out what they're going to do to manage all the servers on site. So there's less cost on the IT side. The IT department can spend more time focusing on other things that are critical to the plant. And also with FLOWatch, when I mentioned when there's a new functionality that we want to roll out based on feedback we've been given, it's an automatic update. We don't have to go to your workstation to, add it onto FLOWatch. It's all done remotely. You log in, we give you warning, obviously, and we tell you what you're going to be getting and seeing that might be new, and we can decide if you need access to it or not. But essentially, you log in and to the website and you would see that new link or whatever it is, that new feature that you have access to. Same thing with the mobile app. And of course, in our industry, security is huge. So, because this is all web-based, it's SSL encrypted. And, we designed it to be a secure platform. As I mentioned, we kept everything so that it is disconnected from SCADA or any other system, AMI, also anything. It's a one-way push. We're not controlling anything. It's more of an overarching operational view of what's going on. And then in terms of business benefits, I mean, now you've got managers and supervisors and the operator who has has instant visibility to all the information out there about their plant or about their system. Like I meant, it's a huge benefit for them to just log into one place rather than go all over the place to try to figure out, where that information is. So we found that has reduced a lot of errors with compliance reporting and increased, they've less violations or no violations from before. And it's streamlining the amount of time to get the information to your fingertips to be able to review your report before you submit it to a state. It also is helpful for data accuracy, quality control. We have, compared to like seeing old handwritten log sheets where I've actually seen calculations on the log sheets, you're looking at much more quality control around that information. Because all those calculations are being done behind the scenes. We set that all up so that the report has the built-in calculations already in there. And then once it's set up, they run it. And also, as I mentioned, preserving that institutional knowledge is key. So now you have a central location, you're preserving, the knowledge from all your operators. And, you may have new folks that come on board to get hired. We have clients, they they don't even bug us for training anymore. They'll train it's like train the trainer. Those who already know how to use it are training the new hires how to use it, and they already know, they have all that information there for them to train them. And also, as I mentioned in the past, it's always been a very reactive approach to any problems that you have at the plant. So instead, this allows managers to have oversight on what their what their team is doing, and it's avoiding any compliance issues, and also being able to actively manage their maintenance crew ahead of before a problem happens, or preparing them to be able to do their budget for what they're really going to have to get done. This is just a quick snapshot of a cleaner log sheet. This is actually an example from one of our clients where now, instead of looking at their paper log sheet, they can log into FLOWatch and see a nice clean version without the calculations and the typos or the scribbles. And then also, for example, a private water company may have multiple plants with different regions. They may want some more executive level dashboards where they can see by region what's happening at the plant. And this was actually a dashboard that was requested of us that we have put together for them. And I just wanted to share a success story from using this type of data management solution by Stone Municipal Water Districts in Texas. The plant manager was having a lot of issues with compliance violations. Was spending a lot of time trying to figure out what was going on. He was sort of fed up with the whole process. And he was using, in fact, if I go back, this was the Bystone log sheet that they were using, but it was all on paper and it was just a mess. And because of that, they had some quality control challenges. And it was a huge time sink for him to prepare the MORs that he had to send to the state every month. So he decided to look for a platform that he didn't want to have more. He didn't want to burden his IT department anymore with server infrastructure or any type of hardware. So he was on the hunt for something that was more cloud-based and easy to use for his operators. And we had a lot of back and forth with them. But through that, they adopted FLOWatch. And since they've adopted FLOWatch, they're now running all their TCEQ, which is the regulatory agency in Texas, the MORs and their DLQRs and some other reports for the state. And they have their operators using these mobile apps and tablets to enter in the data. After we did all the training, we've created some trending reports for them as well that have been beneficial for the plant manager, and he's estimated about an 80 to 100 hours per month of labor time savings. And that's just time. Again, there's intangible benefits as well, as I've mentioned, like preserving the knowledge of the plant. So this is something that we were able to quantify. And from there, he eliminated any issues with reporting errors in his reports. And he wanted, near-time quick visibility to plant operations, so that he has specific dashboards that he's set up and wanted that help him. He logs in from any location. He could be at a conference and log in and see what's going on in his plant. So it's definitely made his life a lot more simple. And also, since then, they've embraced actually using it for tracking their assets and also vendors, and they're doing maintenance activities. Originally, the plan was to just start out with a project that tackled the compliance side, and then from there, like I mentioned, FLOWatch is very easy to expand on. So they started using it for asset maintenance as well on their own. We did very little to have to train them, but we're here with the help desk, so they are aware of that. And to get in just a little bit about how the FLOWatch cost structure is we're software as a service, so we use that type of licensing model. Usually we have, we scope out a specific project, and we have the initial setup and implementation. So there's a cost associated to that because we have to set up the users, the database, make sure, we have everything lined up with what, they send us all their information, their requirements, and then we, configure all the custom log sheets that they want to view. And then we go through this whole training process. But that's like a one-time thing. And then once that's all done and everything's approved with reportings and the reports, it's a go live feature. And, we want to minimize the capital expenses, as I've mentioned before, but it becomes a monthly or annual licensing fee. And we usually go on a per user basis. Some software programs will do concurrent user licensing. We don't do that. It's whatever a client's comfortable with, of course. But we allow, unlimited number of users to get on. Like we're a big proponent of, working with the client to make sure that, let's not have shared passwords and all that, because then you lose the whole audit tracking capability of using a platform like ours. Plus you have like plants that might have shift supervisors. You might as well just give them all access. So we'll work within folks with their budgets around that. But when you're getting these licenses, you're getting access to help desk. It's not an additional fee. You've got, we're managing the servers, the data management aspect. We're doing the backups. We've got servers in different parts of the country for disaster recovery, to cover security, all of that. And, we offer volume discounting. So, all these software programs are not apples to apples. So whenever we always say, whatever best suits your need, just make sure you fully understand what you're getting out of your, out of the cost. And then the other thing we really highly promote to make folks comfortable with a platform is to start with a pilot, tackle your low-hanging fruit, like whatever's the biggest, the pain point that you really want to get rid of first, and then expand from there. We find that that's the most successful approach, other than if you go to tackle the world, it's just such an overwhelming process to figure out from I'm sure for the client's perspective, to figure out, how they're going to go about getting this implementation of a project of that size. And that is it for my presentation. I'm not sure if I'm done a little early, but maybe it'll give us a little bit more time for Q&A.
Hey, Christelle, no, you did a perfect job. You came in actually right on my clock. It's 12:40. So I'm an hour ahead of you.
Oh, perfect.
So that was perfect. So thanks very much. I really appreciate you taking the time to do this presentation. So I do have a few questions here. Some of them you answered sort of toward the end of it, but sure. If you're available, let's go through some of these. And I thought you guys did a really good job. Your product, in terms of sort of migrating that human data and machine data, because that's something that is definitely a struggle for a lot of people in a lot of utilities. So that's really nice. Mm-hmm. So if I jump to the questions, like I say, the first couple that I have, I think are answered here. So the first one, where the data is stored, you mentioned your product's cloud-based.
Yes, we manage our own servers. So we've got servers in the Denver area, and then we've got disaster recovery on the East Coast.
Right. Okay.
Servers. So we back up both sets all the time. So all of that's managed in the U.S.
Right. Cool. So, and so in that case, then the end user doesn't need to worry about TLS certs or domains or anything like that. It's all of that setup and management is done by you guys, including updates and security patches and all of that, I assume. Yeah.
Yep. All of it. Yep. That's all included in how we do our pricing as well.
Right. And you did mention that you're subscription based, and you went through the pricing in a bit of detail there. So that's perfect. So a question, can the data entry form data be shared to any other software? I think you had a schematic there at one time that showed a little bit of it, but are you able to pull any data, or is your system sort of all about retrieving data to it and then processing the data there?
Can you elaborate on the part where you talked about the log sheet that I had?
So I think the question is basically, if somebody fills in a log sheet and puts it into your system, then if there's a parameter there that they wanted to, I don't know, say run a calculation in a SCADA system, could they query an API or something?
Yes. Yeah, we actually created the platform to also export for simulation and modeling and whatnot.
Right.
So
Okay.
it can go both directions.
Right. So you do have an API where somebody can read data.
Yes, that is correct.
Right. Cool. Okay. Perfect. I think that answers exactly what they were hoping then. I've got another question here. And it says, as I understand it, you can pull data from various sources that include public domains. So they're basically asking whether or not you can pull data from sort of public domains. So that would be, I think, like to get weather data from USGS or Environment Canada or somebody like that, or pull different bits of data from public sources.
Yes, we can, as long as they have the ability to, again, like I would think they'd have to have an API or some sort of
Sure, understood, yeah. Yeah, so
in fact,
a lot of cases
we
that
did other data. I'm sorry?
I was going to say is I think the USGS and a bunch of the data that you get from the US government is available for anyone. And I think that they actually provided in JSON and XML, I believe. But in a lot of other sources, you need an API key or something as well. So I think if the customer had that, then you're saying they should be able to query those?
Yeah, in fact, we did that with some agency on the energy side. It was like an energy project that we were working on, and we pulled it from a website, and they had all the instructions of how we would have to pull the information, and that worked. And they gave us near real-time information on, what was it? But energy. It was all energy driven, and then we also have done it for weather. Right.
Okay. Cool. Yeah, I've done, they say in some of the demos that I do, I've done a few things. I always target weather just because it's such a nice piece of data to have. So I've got a few different systems that would, make recommendations based on weather data. So if there was a rainfall warning, then it would identify that maybe you should put your lift stations into a different mode to get ready for the rainfall. Or if there were wind turbines, then it would look at the wind turbine performance and just use an equation to correlate that to what the wind speed is in the area. And also look at the direction to see whether or not it's indicating that the turbines are pointed, into the wind correctly. So there's a bunch of little things that you could do. So yeah, that public data is something that I think a lot of people underutilize, but has some huge benefits. And you say having a system like yours to pull it is excellent. So there's another question here, and it says, understanding security issues, could you push data back into a SCADA system for use and control? And is there a huge time lag? So I think you did kind of answer that a little bit, but did you want to go ahead? And I can probably fill in a little bit in terms of the SCADA system side.
Right. I'm not the SCADA expert here, but we don't allow for two-way control, but I would think that there'd be a way to push information back.
Right. So
and
Jeff,
you might be able to expand that since that you are the SCADA guy.
So on the SCADA side, and in this case, I can only really speak to VT SCADA, but we do provide APIs that can reach out to a public site. So such as a FLOWatch server, as long as the data can come back in like a JSON or XML format or something like that, then you would make your request. And that request can be done securely over TLS, and you can have a username, a password, an API key, whatever. And then that response that you get, you can take that response and then use that as a data source into a control tag. So basically you're querying, and it's query based. So It's probably not something that you're going to query the server every millisecond or even every second. Most of those public APIs are designed to be queried sort of every perhaps minute or something like that. Or if it's weather data, then you may query it even less. So when you get that data, so you're going to query out, get the response from the server, you're going to use that as your data source. And then in a system like VT SCADA, it'll say, if that data source has changed, then I'm going to create a new write, and it will write that out to your PLC or whatever you're using to control. So the short answer is yes, you can do it. It's actually really easy. And I had a customer doing something similar the other day who was using a Python script. So they were taking data, processing it in Python, and then providing that data as an API to write out to make some control changes based on logic that they had developed in their calculations. So next question is, so it's asking, do you have any stats or data sheets? And you talked about this a little bit in your presentation, but anything to sort of support the reduced number of errors or anything like that in terms of, some evidence to justify moving to a system like this?
Well, yes. So I had mentioned in the Texas story, Bystone, they had quantified, it wasn't us, they quantified the 80 to 100 hours a month on
right.
time savings. And that was just strictly for reporting, for the compliance reporting. It didn't include any other use of FLOWatch or, anything else around FLOWatch. So we could easily probably collect more information from our clients around that and get that list of statistics that if this person asking this question would like to get more information, they can contact us.
Right, and you've got your contact information right there.
Yep. So
perfect. So I guess the last question I have right now, and I'll give people a little minute to get your contact information, and then we'll give another minute, and I'll put up the Q&A slide. So if there's anybody out there who's not sure how to answer a question, they say you can enter it in the QA box. I'll put up a slide in a second that shows how to do that. But I'm just going to leave Christelle's information up for a minute, just for anybody who might be copying the email. So while we get into the last question, the user is looking to know, can we update or correct data that's entered in error? And are those, if so, are the corrections tracked, I guess?
Yes, everything is tracked. So we provide training also, not just on logging data, but allowing folks to be able to go in and edit the data. So say if somebody deletes that, it's always in our system. Everything remains in our system and is archived. And we can even create reports that show who changed it and when. So we can definitely make it so that everybody, and then we can also lock out sheets so that people can't change data within a certain period of time, because there are certain rules with certain states where when they're doing their more like text logbooks, they want a lockout period. They don't want us folks to be changing that information. It's very detailed with what users have rights to do within FLOWatch, and we work with the client on what they want the user to be able to do within FLOWatch.
Right. Cool. Yeah. No, that sounds really good. Yeah, I know what you mean with the logbooks and stuff. I used to do a bit of military work, and the engineering notebooks were pretty strictly tracked in terms of how things could be entered, and if you ripped a page out, well, you were in big trouble.
Yeah.
So cool. So that's it for the questions that I have right now. Now, for anybody watching, you should see on your screen there a little indicator that shows you where the Q&A box is. And so if you have any last minute questions, just click that box, type your question in. It'll pop up on my screen here, and we'll be able to go through that. So I just wait for any other questions to come in. They say, Christelle, I wanted to really thank you for taking the time to present today. We really appreciate it. For anybody watching, these will be put online after the fact, so you'll be able to see these on YouTube. We do have some sessions coming up, and so if you want to move from this stream to another stream for the next session, then what I'd suggest you do is not just click on the other link. The way that Zoom works sometimes makes it a little bit complex in the way it hands things over. But if you close the stream and then click the link to open the new stream, then that should work a little smoother for you. We do have 3 more presentations coming up. In this stream, we've got Charles Fiero from Inframark, who's going to be talking a little bit about SCADA system maintenance and lifecycle planning. In the water and wastewater stream, you're going to have Chris Little talking a little bit about an intro to VT SCADA. And in the digital connectivity stream, we've got ZTech, I believe. I'm saying it the Canadian way, which I think will work. And it's going to be a Q&A session on digital transformation. So I haven't seen any other questions come in. So again, Christelle, thanks very much for your time. We really appreciate you joining us today, and I hope you have a really good day. Feel free to stay on if you want to catch the next session. If not, you can drop off whenever.
You're welcome. Thank you.
All right, thanks very much. In our next presentation, we're going to have Charles Fiero from Inframark talking about SCADA system maintenance and lifecycle planning. Hey, Charles, how are you doing today?
Doing great. Hope everybody else is too.
Yes, I hope so. Where are you joining us from today?
North Carolina.
Oh, okay, cool. So for anybody watching, if you're just coming into the stream here, we've got a Q&A box in the bottom here. So the presentation is going to go for about 40 minutes. Then we're going to have a 10-minute Q&A session, and then there'll be a 10-minute break before the next presentation. Charles, if you want, grab the screen share whenever you're ready, and we can get into your presentation.
Just a short introduction. My name is Charles Fiero. I work for a company called Inframark that used to be old Severn Trent company that they divested themselves a couple years ago. My background, I've got a degree in environmental science and I've been working in water and wastewater utilities for 40 years primarily. I did spend 12 years working as an environmental manager at the largest pork processing facility in the world. To give you an idea of the size of that facility, we processed 32,000 hogs a day in 16 hours every day. So it was quite a large facility. Learned a lot of things there. Seen a lot of things, some things I can't unsee. But anyway, Inframark, we are a pure contract operations company. People contact us and they ask us to operate and maintain their water and wastewater facilities. That could be municipal, could be industrial, whichever. We don't own any of these facilities, so it's pure contract operations. We don't have an engineering arm. We don't do engineering design, these facilities can range from anything from brand new to systems that are 40 plus years old. So anyway, the goals for this breakout session is to develop a list, and this is where I want your audience participation, okay, which is a list of PM tasks for control systems, okay. Oftentimes we go to plants, we see control systems, SCADA systems, and since it was installed, nobody's touched it. Nobody's even looked at it. The only time somebody does something to it is when it fails. Lightning strike hits it, something like that. So what I want to do is develop a list of PM tasks that we can send out to all their attendees today. And you can use them in your facilities, or if you're an engineer, integrator, you can use them as part of your O&M manuals, or however you want to use them. And then the next part of it is to talk about hardware life cycles and how to plan and proactively address obsolescence, okay? SCADA systems have been around for quite a few years. The first one I've worked on was back in 1982. And it was run on a DEC PDP 1144 mini mainframe computer at a wastewater plant. They've changed a lot since then. We went into legacy systems like Bristol Babcock, Healy Ruff, etc. Turbotrol, that was that system I first started with. And then they've kind of moved more towards the desktops. So a lot of different systems out there now, and we still need to plan for obsolescence, end of life cycle. So again, we talked about these things. that first plant I worked at in 1982 had a control system, and I was new to that plant, new to operations. I had been a regulator for several years, went to the plant to be a assistant superintendent, had a lot of operators there that had been there for 5, 10, 15 years, and automation was something that was totally alien to them. And it took us a while for them to understand how this could make their jobs easier and better. And it took about, I don't know, about 2 months, and some of that was due to the startup of the system, getting the bugs worked out, etc. But a month after the system was up and running well, if you turned it off, they were screaming at you. So we've gone from, okay, this is a new kid on the block, to something that we can't live without in a lot of plants. It's mission critical, keeps us in compliance, saves us energy, chemical savings, and it also is safety, has safety aspects to it too. So that being the SCADA systems today, then why do we seem to neglect them? They're not usually in a CMMS program. They're not typically in asset management plans. And like I said earlier, until it's broken, and then it's all, then it's a hurry up, get it fixed now issue, they're not really addressed. So the next question is, okay, how do we maintain those systems? Or what do we tell our clients to do to maintain their systems? So we've got several tasks here, and I'm actually going to switch the screen and go to a spreadsheet, which I've started. Okay, I've seeded it a little bit, and this is where I want some audience participation. Okay, because I want to see what you guys think. What should we put in here for PMs? So if you can fire away in the Q&A box, that would be great. I'd love to see some stuff coming in from you guys. I've got some other things I can seed this with, but please send it. Okay.
All right, just got the first one come in there. So it's critical alarm testing.
Okay, great.
And thank you for your correction, Mohammed. I just almost read it as you initially wrote it, which would have been more embarrassing for me. So, Mohammed puts in eyewash.
Right. Okay. Actually, critical alarm testing for anything. I'm going to leave it open for components, because I think it needs to be all. And then the question would be, okay, what do you think as a frequency?
Right. I think, yeah, this is something that you see under commissioning and sort of major upgrades, but really not very frequently, isn't it?
Right.
So again, we've come in with yearly as a suggested for your critical alarm testing.
Okay, great. Thank you. And that's great. Eye washes, oftentimes, you see them out there and they're covered in grime. You're thinking, I'm going to use this to clean my eyes out when I get hit with caustic soda or something. No. And OSHA now has, a lot of regulations on testing those and keeping them clean and everything. But do we have something for alarms? No.
Right.
Okay. How about anything else? Tell you what, I'll put something in here, and that would be and you'll have to pardon me, I'm not a good typist. you know, as part of our due diligence process, looking at new plants, we go out and visit the systems, walk through the plants. It's not uncommon for me to open up a control cabinet, look inside, and there's no drawings. Or the drawings are laying in the bottom, and they're clearly several generations old. So we want to make sure we maintain those drawings. I also like keeping them electronically and in the cabinets. So come on, what else we got?
So what about computer upgrades or updates?
Exactly. Software updates. You've got operating systems, HMI, VPNs, network switches.
Right. And Tim's just suggested security roles and privileges.
Okay. This would be more like the HMI, I would think.
Yep.
And how often do you think you want to do that? Suggestions, Tim? Realistically, you would want to do it at least every time you lose or gain an employee.
Right. So yeah, Tim suggested monthly.
Yeah.
Question mark. I think, yeah, it would be very dependent on the size of your system. And
Sure.
also probably whether or not you had like a Windows Active Directory.
Right.
Right. So we've got a recommendation for UPS battery replacement. It says here you may already have that covered. Yeah, there you go. Yeah, row 7
I've got
there.
a UPS function check.
Yep. And we've got review SCADA asset list.
Okay. Yep. How often do you think we should do a UPS function check?
Yearly is suggested.
Okay. All right. And then let's see, what was the one before that? Was
the asset list.
Yep. Okay. Come on, we got to have some more here.
Historian functionality. And it's suggested monthly.
Okay. Trying to figure out how I can move things around with the screen. So if it
yeah, take your time there.
Yeah.
So I've got a few other suggestions.
System health check. How about call that diagnostics? And PLC. Okay. How often do you think we should do a diagnostic check? Do that quarterly, semi-annually, annually? Okay. Yeah.
All right. Yeah, you go for it there, Charles. I'm just looking at the bottom of the list here.
Yeah.
So it looks like quarterly just came in.
Right. Yeah. I think that's probably a little bit better. Again, dependent upon the size of the system, that's a good question. Let's see, quarterly. Failover checks. You know, redundancy checks. Again, let's leave that at maybe semi-annual. And again, this is something you can configure for your clients. All right. Field. You've got, Tran, you've got annual for that. Actually, in water and wastewater systems, it's going to be a lot more frequent than that. Oftentimes, at least monthly. And when I say, calibrations, this could be field instrumentation checks and calibration. So, like each week you might check, that the DO meter is working properly and is, working close to reference with a field meter. But you would at least calibrate it monthly, typically. So this kind of leads me to another one too, which is one thing I'd like to see more of, we don't see enough of, which would be a listing of all the field instruments, okay, that are connected to the system and what their scales are or ranges, okay? So the reason for that is, let's say you've got a DO meter and it's made by company XYZ and it fails. They're all going to fail. Okay, so eventually, procurement, you write up a PO for it. Procurement calls and they say, well, ABC company is now producing a DO meter, and they're a lot less expensive, so they buy that. Okay, you bring it, you install it, and the default scale on the XYZ probe is, maybe 0 to 5 parts per million, but the default on the new one is 0 to 50 parts per million. Well, how's that going to look when you hook it up and it talks back to your SCADA system? Okay, you're going to get readings that are going to be all screwed up. So okay. And yes, diagnostic checks, continuous process, yes, but oftentimes the operators that are running these systems may not see PLC faults unless it's enough of a fault to create an issue, and then you get an alarm through the SCADA system. But but I agree. server drive space availability. Oh yeah, yeah, yeah. You don't want your historian running out of space. It's an annual, yeah. Client communications. Yeah. Okay. All right. We've got software updates. We don't have a frequency on that. I'm thinking for your operating system, your HMI, and your VPNs, that's probably going to be more frequent than your network switch, than, say your PLCs and programming languages. So we want to just leave that as you want. Okay, anything else? Tell you what, okay. Let me throw out some of the ones I've got in here for this that you can, that's not, yeah, there we go. Okay, so I think we've caught a little bit. Obviously, to do a PM program, you're going to need a complete inventory. You want copies of your latest programs for, and latest versions of the programs. We talked about version control. Log into the CMMS all the work that's been done on the system in-house or by an outside contractor. If somebody comes in and replaces an IO card, let's keep track of that. If you keep replacing the same IO card, there may be a deeper problem than just the IO card. Obviously, instrumentation, field equipment. I've got one that I called housekeeping, which includes function checks for the UPS systems, your heaters, your lights, any cooling devices. How many times have you gone into an old control cabinet and you open it up and there's a wasp nest in there? Yes, let's keep the housekeeping down on those. Log the errors that come up in the system and any corrective actions that have been taken. Nuisance alarms, a pet peeve of mine, mainly because to me a nuisance alarm is one that probably doesn't need to happen anymore. It's alarming a piece of equipment that may not even be there anymore, or there's a failure in the system but nobody's addressed it. So OSHA is actually supposedly coming up with regulations on that particular aspect because it's a safety issue. If you got a lot of nuisance alarms in your systems, your operators become numb to the alarm and tend to ignore it. Here's one I know that Dave would be glad to talk to. Maintain the annual software license renewals for the HMI firewall devices. Okay. I've gone into a lot of different plants and okay, they've got an HMI that was put in 10 years ago, hasn't been updated since it was put in. It's running on Windows XP. How secure is that? Not to mention, you look at other things, and your VPN, the switch is outdated, obsolete, and you can't get updates for it. Again, a big security issue. So, Okay, I think we got all the others in there. I will fill in what I've got in the spreadsheet here, or in the PowerPoint with the spreadsheet, and you know, and I'll be glad to send it out to everybody that was in the session today. And feel free to use it. It's not proprietary. It's not copyrighted. It's yours to use and abuse. So, okay. So let's jump over to asset management, lifecycle planning for control and SCADA systems. And some of you may know much of this already, but I talked earlier about some of the legacy systems. Up until 2010, I was actually working with a plant that had a large portion of Healy Rough still running in the plant. The plant was upgraded and all that was replaced, but where are you going to get parts for any of these systems at this point in time? It's going to be hard to find that. PLC's life cycle around 10 to 15 years. And these are define these as 4 parts of the life cycle of the PLC. You've got the development phase. The manufacturer is developing a new PLC. He's got a new CPU, new components, etc. He's all doing a development. During that time, he's not selling these units, okay? He's just developing them. Then once it's finalized, ready for sale, it goes into the active sales phase. And that's when, if you're an integrator, that's when all the sales reps are coming to your office saying, I need to show you this new PLC we just developed, etc. Okay. Active sales phase is when, they're out selling it. During this time, there's still some development and upgrades going on to the product line. Okay. The after sales phase, they're still producing the product line, but there's usually not a lot of active development going on with the product line. They may have some minor updates, security updates, things like that, bug fixes, but for the most part, they're not really developing a whole lot of new stuff to that product PLC. And then at some point in time, you're going to hit an obsolescence phase, okay? And that's when, they're not selling it or producing it anymore, okay? So that's critical because at that point in time, you're not going to have access to purchasing these things from the manufacturer or their sales rep organizations. You're going to have to go to some third party. So, third party, is somebody that's gone out there and said, okay, I know that, 3 months from now, this PLC manufacturer is not going to make, their smart PLCs anymore. So I'm going to buy up all the stock they've got and sell it after, they stop making it. So anyway, so then the question comes for your system, when was it designed and installed, and where in the life cycle process was the PLC at that time? Most times you're well in the active sales phase for these designs, but that may not be completely true for all systems. So again, your system might be obsolete if the manufacturer's out of business. The model's no longer made or supported. You have to use Windows XP to reprogram it, or you require a serial port to program. When was the last time anybody bought a laptop with a serial port on it? Getting hard to do it. We work with an integrator, and he's got a couple legacy laptops, and one of them is such that you actually have to hold your finger down on the laptop case in a certain space to get it to boot up. But they're afraid to get rid of it because it runs programs they can't run on anything else. Last but not least, if you have to buy your parts off eBay, your system may be obsolete. So HMIs can also fall into the same category, okay? They're running on Windows XP. They haven't been updated in several years. Like I said, we were at a system running a HMI that was installed in 2010. And, that was version 1.0, and, the current vendor's up to version 12. Also, remote login software to access the system can be a cybersecurity issue. I much prefer using, clients to access the system rather than, log me in or some of the other sources where, they actually take control of the computer. We had a plant where they used one of these remote login softwares, and you could go and see how many attempts were made, and it was constant all day long, somebody pinging that IP address trying to get in. Not fortunately they didn't get in, but that's not something you want to be doing. So so the question is, as an integrator, or if you're actually running these systems, working in the plant running these systems, or an engineering firm, and your client's got, a system that's 10 plus years old, has obsolete hardware, software, then it's time to have a discussion with, either your bosses or the clients about, developing a capital plan for the, replacing the system or updating the system. The America's Water Infrastructure Act and NIST cybersecurity framework and the current cybersecurity issues, excellent opportunity as a starting point for that discussion. So, have that discussion, start that discussion. If your clients are, municipalities, they tend to like a much longer lead time for developing a capital improvement program rather than coming to them and telling them next month you need to spend X number of dollars to replace this system. They'd rather be able to budget for it and plan for it. So, questions, comments? There's my contact information. I'll be glad to, talk to anybody that wants to discuss this. Again, the spreadsheet for PM tasks, I'll update it with some additional things that I've got and be glad to send it out to everybody. But other than that, thanks very much, and I'm open for any questions. Sorry, I'm 4 minutes short.
Nope, that's perfect. Thanks very much, Charles. So if you have any questions, that's that QA box that we were using earlier for some of the participation thing. Just put your question in there, and we'll get it off, and Charles can answer those as they come in. Thanks very much for your presentation today, Charles, and for making the information that you put up there available to anybody. I guess if anybody wants that, they can reach out to Charles at his email there. I think that we will have a list of the people who registered, but we might not know exactly who was in this session at this time. Right. So,
it might be easier if they email me, and then I could send it to them rather than doing mailing. Yes,
definitely.
I'll be glad to send it to them. And again, they're free to use it, distribute it, however they want to do with it. This was, developed by us for us.
Right. Cool. That's really good. Some of the stuff I was just looking as you were going through your list there, paying attention to, some of the things that affect us on the SCADA software side. And it was nice to see that we do have some built-in tools for most of the things that you mentioned there. And some things that I hadn't really thought of doing on a regular basis. Like you talked about checking the redundancy or verifying the failover. And I know there's many places where you may do this. You may have communication networks and all kinds of different things. But on the SCADA system side, I was realizing that it was actually pretty nice to be able to do that in VT SCADA by just flipping the backup in the primary server with just basically a click of a mouse. And then while you're testing, if something were to happen, then you still do have that backup server available as well. It's not like you're taking one completely offline. You're just changing the services. And then we've got a little GUI, in fact, that you can use to see exactly which services are being used by which computer. So anyway, that side of it was really cool. And like you say, it was great to go through that list. And like I say, as I'm making some mental checks as we're going through it, seeing what we do well, and if there's anything that in there that we didn't do well. So
I posted up another one that was developed also. So obviously, there's more into this. I'll integrate that into the spreadsheet also, so that like I said, you can use it however you want, and I'll probably leave the frequencies, to be filled out by everybody. But,
Right, cool. And if you're watching this, why don't you let us know in the Q&A section whether or not you guys feel that, is this something that you guys do on a regular basis, or is it something that needs work at your site, or just kind of trying to get a general feel for how people feel about how they perform at their own location, and whether or not this is something that they want to work on. And while we wait to see what people are saying there, Charles, how do people generally get started with you if they're interested in bringing you on as somebody to do this kind of work? Do they just reach out and then you guys come on site, or is there some sort of back and forth up front, or how's that process normally look?
You're talking about for contract operations?
Yeah, for if you're just starting with a customer, tell us a little bit about basically what that process kind of looks like.
Sometimes we contact potential customers because we see that they've had a lot of regulatory non-compliance issues or other type of issues, and try to initiate a discussion that way. Sometimes they come to us, they give us a call, they reach out to other people that know us and recommend us, and we sit down with them and go through it. And then there's an occasional RFP, request for proposals for firms to come in and operate and maintain their systems.
Right. Okay.
It's a oftentimes a long lead time process, because we're working on the client's schedule, not our schedule, and I've seen it, okay, we'll get that contract signed, and then all of a sudden, no, we got to discuss this, we got to discuss that. So it all changes.
Right. Yep. Very good. Yeah. And if, at least if you came in partway through, I just put up a slide there that shows where no, I didn't. I will just put up a slide here that shows where that Q&A box is. So you should see there's a little Q&A box in your Zoom console. If you have any question or anything, you can type it in there and we'll get to that. Cool. So Charles, tell us a little bit then, what's the timeline normally like for you? If you come in, you were talking to somebody, is this something that you guys normally get through this in like a month, or is it a process where you'll make an initial plan and then you revisit it, and kind of as things go on, you make kind of a progression plan until the customer has a fairly long cycle, or what's that look like?
It can range from anywhere typically the shortest lead time is probably 3 months, simply just to get through the entire process. Once the client says, yes, we want to do this, we've given them a proposal, then, they've got to, have the board meetings they require to, approve it. And then there's, obviously the legal reviews of the contract going back and forth, insurance requirements, liability, levels, things like that. And that's after we've done due diligence, which is to go visit the plants, things like that, take a look at them, see if there's any real issues prior to us taking it over that we would need to look at addressing, on day one, et cetera. But 3 months is probably about the shortest time frame. I have seen projects take up to 3 years,
Right.
to come to fruition or not, type of thing. It kind of varies, and some of it depends. We're very susceptible to changes in leadership at the at the client level. Elections can change things, things like that. So it depends, and a lot of it depends on their reason for doing it.
Right. Yeah. So I say we're just getting close to the end here, and then once we get to the end of this presentation, we'll put everybody into sort of a waiting room or a lobby for a little bit until we come back up to the top of the hour, and then we'll have our next presentation. So you'll have time to grab a coffee, do whatever. So Charles, I guess for your closing, then, if there was one thing that you see over and over again that anybody listening can say, yes, okay, this is one thing we're going to do and we're going to take a look at because it's something that gets missed a lot in the different groups that you work with, what would be that kind of your number one piece of advice for anybody who's operating a plant?
Based on control and SCADA systems?
Yeah, exactly. Sort of based on
Okay.
the theme of your presentation today.
Yes. These systems are critical. They're critical to your operation, whether it be a SCADA system or even a control system or embedded control system. That's what's running your operation. Think about if you went and turned the control system off, what would happen? How much effort would you need? And because of that, let's take some time and effort to understand what we need to do to maintain these systems. They're just not a plug in, get it running, and then forget about it until there's a problem type system. They need a little bit more than that, just like any other type of system you might have at your treatment facility. Most of them are very robust, very strong, and will run for a long time. But you don't want to find out in the middle of the night after a lightning storm that your PLCs aren't made anymore. And
right.
okay, how do I get that? Or your HMI was running on Windows NT, and oh well, I can't buy a computer to run Windows NT anymore. So that's not the time you want to be finding this out.
Right. Yeah, and we've certainly seen that where somebody's system goes down, and as you described, a common one that I do see is people who are using USB to COM port adapters, and they run to the Best Buy or whatever, pick up a new laptop, put everything on it, plug in the adapter, and they don't get good communications on that. It worked on the old laptop, but it doesn't work on the new laptop. And they say those USB to serial adapters is somewhere that I've seen that in more than one instance where
very, very problematic. Your best bet would be to some of the bigger PLC manufacturers actually made cards to put in that actually will do their own serial to Ethernet conversion. And if you can't replace the PLC at this point in time, if you can put that in, you're going to be I think you'll be ahead of the game.
Right. And I know from our perspective, when it comes to doing things like redundancy or being able to put things in more displaced areas, doing it over Ethernet is much, much, much easier from the whole networking perspective than it is to do it over serial. It also allows you to move things further off site so that you get geographic redundancy as well as sort of application redundancy.
Yep, exactly. And so, you want to do that long before you have to do it.
Right. Yes. Yeah. I think most people can probably think of that panicked phone call that in retrospect was really easy to prevent.
Exactly. Yep.
So, cool. All right. Well, thanks very much. Like I say, we're just kind of coming toward the end of our time here. I don't have any other questions sort of queued up for you. So again, thanks very much. I really appreciate you joining us. Hopefully we'll see you guys in the future for another one of these Automation Village projects.
No problem. Glad to do it. And I want to thank everybody that was on today that, helped us come up with this list of tasks and the input from them. Doing these things, remotely, very different. I'm used to doing things in front of audiences. It's a little bit easier for me to do that than do this because I don't see the audience, feedback, things like that. But I appreciate everybody that participated. And, this was my attempt of trying to get more of a feedback back and forth type discussion going rather than just me sitting here reading screens off to everybody. So hopefully they got something out of it.
Yeah, cool. Thanks a lot. Yeah, like I say, it was great as you're going through those things. I know myself, I'm kind of running through in the head. Okay, how do we handle this? How do we handle that? How do we handle this? And how easy and efficient is it based on the fact that some of these things you're saying, yeah, we really should be testing these way more frequently than perhaps oftentimes is done. So anyway, that was really great. Cool. So thanks again. They say is if you want to stay on, you're welcome to listen in on the next presentation. But if you have to go, we understand. And so feel free to sign off whenever works for you. So thanks very much.
Thanks. Take care.
Cool. So for everybody on, we do have 3 streams going on at the same time. So you're right now watching the design operations and planning stream, but we do have a water and wastewater stream and a digital connectivity stream. And in each of these streams, the next presentation, which will be happening at the top of the hour, and again, will be 40 minutes with 10-minute question session. In the water wastewater stream, we'll have Xylem talking about site selection using survey vehicles, and those are, for the most part, autonomous vehicles that will go around and do a profile, so you're able to set up assets in ideal conditions and get a little bit better data from those. So in this stream, we'll have CDM Smith talking about the approach to automation, and this is kind of a high-level discussion about going into a project and some different ways that Dave Ubert has seen this and done this, and talks a little bit about what works well for different scenarios. If you're on the digital connectivity stream, we've got 4RF, who's going to be looking at whether your legacy communication system is holding you back. And they're just going to talk a little bit about some older technologies for telemetry and other things, and areas where those may be becoming bottlenecks that an upgrade there might open up a whole bunch of opportunities with the rest of your SCADA system. So you're suggesting your system is often more powerful now than your network in certain cases. Okay, we're just coming into the last presentation for today, and joining us for this presentation will be Dave Ubert of CDM Smith.
Hey, Dave, how are you?
I'm doing very well. How are you doing today?
I am doing the same. Thank you.
Cool. So, and the picture you gave us for this is not you on vacation. This is actually down in Florida where you live. Is that correct?
That is right outside my office.
Right. That's very nice. I will. It does not look like that where I am. Although today is particularly nice. They say we only get a few months of that. So how are you doing today?
Doing very well. It's another sunny day in Florida.
Right. Good.
Things are good.
Cool. Well, that's excellent to hear. So I know you're through some of the rainy weather now and into your summers.
Well, we usually get rain in the afternoon. And
right.
That's typical for this time of year. I'm a native of Wisconsin, so I moved down 16 years ago, and I know what cold is, and I know what hot is, and I prefer hot.
Yes, that's yeah. I think a lot of people would agree with you there. So yeah, so today you're going to be talking about the idea approach to automation. It's design build versus design bid build, and this really comes back to project planning and other things. And this is before even the release of the RFP. Is that correct?
That's correct. Yeah, this is an approach that would be selected by owners of municipalities, or if it's industrial, the owner of the facility. And they would select a path to go down. And there's this presentation hopefully will unpack some of that, but I like to go into some of the meat of it, specific to automation and some of the nuances that can occur and things that people should consider when selecting a path.
Right. Yeah. And so for the people just joining us, for the rest of you, I know you've heard this a million times already, but if you're just joining us, you'll see in your Zoom console there's a little Q&A button. And if you have any questions during the presentation, just click that Q&A button, type your question in, and the presentation will go for about 40 minutes. And then after the presentation, we'll have a 10-minute roughly session where we'll go through those questions. If you have follow-up questions, you can just type in any additional information. So as things come up, just put your questions in and we'll get to those at the end. So Dave, whenever you're ready, feel free to grab the screen share there and we can get into your presentation.
Very good. All right. Well, thanks everybody for joining us today. This is a topic that is near and dear to my heart for many reasons. So basically, I want to give you a quick overview of CDM Smith and myself. I've been with CDM for about 14 years now. We have over 70 years in the industry, founded in 1947, with about 5,000 employees and over 125 offices worldwide. This is just a map of the U.S. where we have our offices based. We're headquartered out of Boston, Massachusetts, but again, I'm down here in Maitland, Florida. And let's see, we've got offices. We try to locate offices specifically where our clients are so that we can serve them well. But we also have 5 design centers throughout the country, and we use those design centers to develop multidiscipline projects, and we'll talk about that in a little bit. So I just want to walk through the similarities, differences, pros and cons, and some things that you should try to avoid at all costs when you're making decisions to go design build or design bid build. There are other alternative approaches. There are several. They're some are an amalgam of different approaches, and I'll talk a little bit about that, but I'm pretty much going to focus just on these 2 concepts of design build and design bid build, and I want to try to focus mostly on the automation side of the design build and design bid build process. So before we go anywhere, as Dave and I were just talking before, this decision is really a client decision. The owner of the facility, of the project, has to make a decision on how they want to execute a project. So a project can be anywhere from a SCADA upgrade project to a major undertaking of a brand new water plant, wastewater plant, industrial plant, etc. So the part on the client's end is way up in the front before the RFP, before any type of solicitation goes out. And in order for a client and owner to make their decisions, they have to look at schedule. How fast do they want this project done? So in a design build, for instance, there's no bid process. They're just going to submit an RFP, solicit for design builders to design and build their project. So there is no bid process, so that goes a little bit faster. So schedule is improved when you go design build typically. Then they have to look at budget. Everybody has a budget. You have a certain amount of money you want to spend on a project, and so when you're looking at budget, you have to look at the engineering costs to design a project. Again, if it's a multidiscipline project, there are a lot of things that go into looking at how much things will cost. And actually on the budget side, oftentimes design bid build is a good way to go so that you can control your costs, and you don't step forward until you have the budgeting and the funding in place. Then there's the big one for this discussion is risk and responsibility. Typically when you have a design bid build, you have risk and responsibility spread across different entities. The owner is taking on some of that risk for themselves for the project. There's an engineering firm, an architect engineer that's developed the design, so they partake in some of that risk and responsibility. But when you do a project design build, you're really putting almost all that risk right on the design builder. So it's another thing that that folks need to look at when they're walking down this path. Now there's fixed costs and the unknown, and that's when I was talking about the budgeting. You have design bid build, that would be DBB on the screen, abbreviated DBB. So you have engineering costs, and in the design bid build process, the client would go out, they would solicit bids for engineering, and then the engineer would put together the bid packages. They go out, they solicit those bid packages, and you have all of these costs known once the bidder wins is awarded the project. Now you move forward. In construction, you have all of the costs known ahead of time, plus of course some things that come up during construction. And usually we like to say, depending on the project, about 10% might occur in some sort of change order. When you're doing a design build, however, oftentimes those costs are reduced. So in design build, you develop a GMP. This is entering into somewhat the unknown as they go through the design process and developing a final GMP. That's a guaranteed maximum price. So as you move through the design process, you start to develop your GMP. If it's too much, of course, then you have to do what we call value engineering, VE, and that can be used on both design build and design bid build. So oftentimes the cost of construction is too much, and then you have to start looking at ways to save money. Now on the automation side with the VE, I love those sessions when we're doing engineering, say a multidiscipline project, big design project or a big design build project, and we run into budgeting constraints. We have to go back to the table and sit with each other and do what we call a VE session. What I love about that is I don't really have to do much, because in the automation world, compared to all of the other disciplines, our piece of the puzzle is not the most expensive one by far, and it is one of the most critical ones. So there's not a lot of savings when we run into a project, say it's $100 million, it's a brand new water plant or something like that, and they come to us and they say, we want to do a VE. And I sit there and I say, well, I can take out a couple PLCs and we can save you about $50,000. $50,000 on a $100 million project doesn't really cut the mustard. So VE sessions are typically not very exciting for me, although I do participate and help out on the electrical side. And coming up, I do try to come up with some unique alternatives to our approach. Then I like to say, automation as an influencer. These are on smaller multidiscipline projects. So in automation, when it comes to a design or a design bid build, at CDM Smith, we do projects of all sizes. We really aren't looking for just big projects or small projects or middle-sized projects. We do all kinds of different size projects. And oftentimes they're the smaller ones. So they have maybe an automation piece. And then we'll have, for instance, I did a project for a control room upgrade. And the control room upgrade included a SCADA upgrade. So we upgraded the client's SCADA system, just the software on the HMI side, and we updated their control room. With the control room, I know all the pieces and parts, but I need an architect. I might need an electrical engineer, maybe even some structural engineering, moving walls and things like this. So the smaller multidiscipline projects, we really like the automation team, in this case, to lead the project as the general contractor. So it helps some folks in the automation space, in the system integration space, to have these licenses to do work as a general contractor. And I call that just automation as an influencer. Those are small, multidiscipline, or automation-only projects. So let's get started into the meat and potatoes. I just say, in the beginning, when you start out this project, the design build and the design bid build, from an engineering perspective, has a very similar process in the way it starts out from an automation perspective. So I'm just looking at, not contractually, because contractually these two obviously are very different, as we talked about before. But the automation process is very similar in the engineering side up front. In the design process, we're doing workshops just like we would do if we were doing a design or a design bid or design bid build. Either one, we're going to do workshops with a client to help ourselves, our team, understand our client's needs and the needs of the project in particular. Some of the things that we look at: instrumentation selection, controller selection, software selection. These are all things that we have to take a very close look at it from an automation perspective. So on the instrumentation side, we have a lot of very good relationships with instrumentation vendors. That's one of the things I really like about my job is interacting with these different instrumentation vendors, the different system integrators that are out there, all the vendors with the different PLCs that we deal with in our designs, software vendors like Trihedral. And of course, then there's the vendor systems coordination that has to take place. So oftentimes, for instance, a water plant might have an ozone process, and that ozone process has to communicate to the rest of the SCADA system. And so how do you do that? It's not as easy as just plugging cable in and off you go. So there's a lot of things that take place up in the front end, and a lot of these things are very similar when it comes to making the choice of design build or design bid build. Very similar. And again, contractually, these are very different. So these two approaches to a project, to constructing a project, they begin to diverge in the early stages. So typically we do like a 30, 60, 90%, and then we develop a construction set 100% and then a construction set. So early on, like around the 30%, these two really begin to diverge, and you start to do things a little differently on the design side that's including bidding instead of the one including only building. So you do design build. There's going to be different aspects of what you're looking at early on in the stages of the work. So design bid build, again, steady paced design development. And so if you have time in your schedule to build this project out, design bid build really is a very good road to go down. There's more owner interaction time on the design. It's very interactive. I'm really a fan of both because my background is, I was a system integrator back in the day. As I said, I'm from Wisconsin originally, and I partnered with 3 other guys. We did a system integration firm, and it was a lot of fun. And I had that construction experience where I was always involved in the either a design or I was involved in implementing the system in the field. So I got a little taste of both. And then I came over to the engineering world and enjoyed the design side, but also the construction side. That's where all the fun is, really. And sometimes the fun isn't so fun, as some of you may know. So the steady pace of design development and that owner interaction time in the design bid build for me is quite enjoyable because you really have to work closely as an engineer with the owner. On the design build side, the relationship is a little bit different. It's faster paced, so things are moving much quicker and there's not as much time to sit and really think through things. So you really have to be sharp on your feet from an engineering perspective, and you have to be ready to help owners make quick and good decisions in all of those things and more that I had on this slide before. So we talked about instrumentation and software and hardware selection. If an owner doesn't know, and this happens quite often, if an owner doesn't know what type of HMI software, for instance, I've done many different workshops with owners and with several vendors, bringing them through, showing their latest and greatest wares, and helping the owner to make a decision on the type of software that they want to use. Let's face it, the software that is going to be used on these projects, you're going to install it, you're going to create graphics, you're going to create control algorithms, and the operations staff is going to have to live with this product for the rest of their careers typically. Sometimes they do get overhauls in the middle, but if you're working with people, working with operations staff, these systems should be good to go for, we say, 15 years plus in the automation world. And so when I install a system and I install software for a client, it's going to be there for 15 years. And that's why it's so important to make the right decisions up front. In the design build world, we're fast paced, so we're moving fast. I don't skip that step necessarily. We just did a project for the city of Houston, which many of you heard about if you were on the presentation last week. I talked about the city of Houston. The The Trihedral folks were in Houston. It was a lot of fun. But that project, we actually did the workshops and brought some vendors through, because that one piece, that SCADA piece, is so important. The HMI piece is so important for the operations staff. Nice to be able to say VT SCADA was the selected vendor for that. And so in the design build, you also establish partners. So you partner up with subcontractors very quickly, typically with those that you know, and you establish pricing estimates early on in the project. So this is key for, this is really where the divergence begins, is you don't have a good idea of how much this is going to cost quite yet, but you are developing these cost estimates early on, and so you're trying to develop your design as quickly as possible. So here's a couple of items that make this a little bit different, where there are some discrepancies and some differences in how we approach things. Here's one that I love to talk about: control narratives. They're so important on a project because these control narratives developed by the engineer are going to tell the integrator who's ever programming the process how this thing is going to work. It's critical. This is one of those critical pieces that you just want to make sure that is done correctly. Now, in the design bid build process, we have a little more time, and we can put time into these control narratives. When I do these control narratives, I'm interacting with my process engineers to develop these control narratives. And when we interact with these people, we really have to understand what they've developed, maybe hydraulically, maybe structurally, maybe there's some structural concerns. But overall, it is a plant operation, and there are multiple control narratives. People call them control loops or control narratives. Basically, this is how the system is going to work, and it just takes time. So the design bid build process is a very good process to use when you want to develop some very good control narratives up front during the design. These will go out. These are going to be bidding documents. So an integrator, a system integrator, is going to look at these in a design bid build. They'll be subcontracted to a general contractor, and they're going to look at these to say, okay, how hard is it going to be to program this system? Now, when I was doing system integration, I would look at these control narratives. I could really just, at some point in my career, I can't even kind of put my finger on it, but at some point in my career, I was able to not even look at the control narratives. All I would have to do is really look at the P&ID drawings to get a feel for how complicated it's going to be to develop control algorithms to control these processes that are shown on the P&IDs. So if a design engineer does a good job with his P&IDs, and a system integrator can pick up those design documents and really look at the P&IDs and say, you know, I've done this before. This is the amount of content I need in order to program this thing, whatever it is, across the plant. So you have, you may have some sludge systems, some gravity filters for water plants. You may have ozone systems, like I said, and vendor systems, and you have to interact with those things differently. But if you look at them from the P&ID standpoint, a good integrator can look at that and understand the content of what they need. Now, the reason I talk about this so intently is because in the design build process, it's going fast. So you have this, you don't have as much time. So you develop, during design builds, I'm developing conceptual control narratives and trying to get a feel for how this plant is going to operate. And these are developed alongside of all of my other design. There's a lot of work to be done in a smaller amount of time. And so at the end of the day, I know that I have to develop record documentation. And so it's going to be a lot easier for me to develop record documentation because I'm in it the whole ride through in design build. So I'm doing the control narratives up front. Then I interact with the process engineers. Changes are a lot easier from the design build perspective because if I put content in there and it's not quite right, but the content is there, I can tweak the content instead of one thing, I do another thing. But I have everything in there, so I know about what it's going to take to do the work. So that's control narratives. Talking about PLC programming, this is an interesting aspect of the design, bid, build process because really when you do changes to narratives, it's going to cost you money because you didn't, as the design engineer, if you didn't do a good job developing control narratives, any changes, and I probably would say major changes, that's just going to cost you money because those changes are done after the fact. If you're the design builder, it doesn't matter. You're the one that designed it. You have to make the changes on your own. So there's a major difference there. You have this new perspective in design, bid, build. So as the design engineer, I develop P&IDs, I develop my control narratives, and now we bid it out, we give it to a general contractor. He has a system integrator that's going to do this, this programming. And it's kind of nice because now you have a new perspective. Maybe he's got a different way that he wants to do things. He's done a project recently, and it's gone real well by doing this, that, and the other thing. My ears are always open. I like to hear. I love being on this side of these projects because there's so many different perspectives in automation. So it's actually a good thing in the design, bid, build arena that you get this new, fresh perspective of somebody looking at an engineer's design. And I also put a bullet here. Engineer can also provide programming services. So this was happening way back when I was doing system integration. Engineering firms started to develop a system integration piece, and so in order to help clients, they would hire programmers and have a small crew of programmers to help certain clients and develop programs and do that. Well, as a system integrator, I thought, well, that's kind of strange. But as I kind of moved down in my career, I started to understand more of what was going on. Here at CDM Smith, we do exactly that. We've got over 80 automation engineers that can provide all sorts of automation professional services, and one of those is programming services. And so that's a different kind of contract where you do a design bid build, and you can have the engineer contract directly with the owner. We've done that several times. It's not always a good idea, and so we don't do it or don't encourage it in every scenario. As a matter of fact, in most scenarios, I don't do it. But it is another one of those options that I was talking about before. Now, looking at the design build, again, the changes to the narratives are much easier because you own the whole thing. You own all the risk. So those control narratives for the PLC programming, you own all of that. The nice thing about design build is continuity, and you'll see this word come up again and again when it comes to design build. When I'm working on a design build project, I know the client from start to finish, and so you develop relationships, and it's actually a great experience. It has been for me, meeting all the different people, operations staff, and just kind of walking through the entire project with them. So that is a positive, the continuity on the design build side. So here is a complicated one, piece of the puzzle that really over the years has become more and more complicated, and that's the system architecture. These system architectures are getting to be so complicated. When I first did system integration work, I literally would buy a computer, load the software, do my programming for my PLCs and my HMI on that computer, and I would turn that computer over to the owner, and he would run that computer and run his entire plant, and that was it. So there was no major network pieces that I had to deal with. However, over time, I had to start to become this network guru, and at the time, I didn't necessarily like that. Now I'm it's totally changed. I'm into cybersecurity, and I'm Security Plus certified, and so this has become of great interest to me. But these pieces of the puzzle are the most important pieces of the puzzle, because if this system doesn't work, your system isn't going to work. I mean, it's quite simple. It's that simple. Your communication system around your SCADA system has to work, and not just work, but work really well. You really have to be able to rely on it. And so I just say it's getting very complicated. There's many different approaches to this. This is a real problem when you do either design build or design bid build. You run into problems with contractors that want to do it a different way or use different hardware. Everybody likes their own stuff, and this stuff is better than that stuff. And I've heard the whole line, and I have to stay ahead of the game. But there's different hardware servers you can do. You can load software on a computer, on a server, and that's your control system. You can virtualize your servers, and now it's a virtualized system on a piece of hardware that's a little bit more expensive and beefed up system. You also have remote connections. Now you really have to monitor the door. You have to incorporate cybersecurity architectures that are trusted and true. And when it comes to cybersecurity, I simply say certifications are critical. So when you have cybersecurity involved, and you're doing all these systems nowadays, that's a whole nother topic that I've done multiple times. It is absolutely crucial that you get people that actually understand the cybersecurity world really well from your perspective, particular perspective. So if it's industrial, it's industrial. It's water, wastewater. You should have that understanding. Screen development. This is a real good one because you have some different approaches to for both of them. Design, bid, build. You don't obviously design or develop any kind of graphics until you're well underway under construction. So you have to go through all sorts of submittal processes and after award, and you got to get all of those pieces in place. Sometimes they're specified kind of loosely. I can't specify draw a red line at a 45-degree angle on the screen to represent blah, blah, blah. So it's, as you can imagine, I can describe screens to a certain extent in text in my specification, but I can't nail it down like I really would like to. Again, somebody's going to live with this for the next 15, 20 years. So you have this submittal process in the design, bid, build arena. In design build, again, you can get started early and things are moving a lot faster than in the DBB world. You're moving fast, and so the interaction with the owner begins right away. You start to know who's who, and you start to sit down with those people and understand how they like to see things. There's multiple ways that you can do this. We do high performance graphics. That's the latest and greatest, and it's actually a preferred method for me from my perspective. But some people like the P&ID style 2D drawings, and that's the way they like to see things. We kind of went through an era of the 3D graphics. I like to do some 3D graphics if you have large screen TVs. So if you have maybe 2 or 3 or 4 3D graphics, you can present those on screens when you're doing a tour, or you got the mayor coming in. So I coined it the mayor screens back in the day when I actually did a SCADA system for a very small town in Wisconsin, and the mayor showed up for training. So that was kind of fun. And I realized that this guy doesn't care. He doesn't know anything about this stuff. He just wants to see what the money was spent on was good. So he was looking for those pretty graphics. And finally, that submittal process. There still is a submittal process with the design build. It's just much faster, and it's much more streamlined. So you can get started earlier, and screen development can be kind of one-on-one with the owner. And again, there's different ways to approach an amalgam of a project. You can kind of mix the two together and get what you need out of a project. What I like to look at both of these methods is I like to make sure we partner with system integrators all the time. I oversee the automation group for CDM Smith, and I'm a big fan of teaming arrangements. As you can imagine, there's multiple personalities on a construction site. Been there, done that. And if you can develop a teaming approach on both the design bid build and the design build side, you're halfway to the win. So in the design bid build, the general contractor teams with the integrator, and then they formulate their other team. So the automation and electrical projects, those are the smaller ones. We like I said before, we like the integrator to actually lead those projects instead of an electrical contractor, especially if it's mostly automation or SCADA related. Typically, I&C are provided by a single integrator. So you have an integrator. They provide all of the I&C work that's on P&IDs and specified throughout the specifications. They provide some instruments, but they rarely provide all the instruments. And so here you have a little bit of a problem that can creep up where the design has to be very clear and there has to be clear separation between vendor systems and who's providing what. Because typically, I remember, again, well, this is back when there were fax machines, started to reveal my age, but these guys would fax sheets of specs and drawings to us, and we'd have to cost out a project with faxed documentation of whatever he selected. And so sometimes it's not very clear. Now today, obviously, it's totally different where we have access to PDF drawings. But you must, even in the design set, is what I'm focused on, is you have to be very clear about what you're talking about. On the design build side, a single entity owns the entire project. So that's that risk thing that we were talking about. So even if the design builder is not producing a good design and he forgets something, that's his problem. Integration should come from that DBB. It should be design builder. The owner needs clear contract language for this. There can be no ambiguity in that part when you do a design build project. When you're doing a design build, the owner needs to do their homework. Typically, they would hire an engineer to develop the contract language, but not all the time. And it's always good to have an owner's rep on these projects. So a couple of pros, go through these real quick. Design, bid, build. The owner's engaged in the design. The design is fully developed. The engineer provides bid packages. And there's multiple bids for construction. So oftentimes, but not all the time, they're looking for good competitive bidding. Obviously, that's a kind of an obvious thing to look for. I want competitive bidding, so I want people to bid against each other. But oftentimes they weight the technical as well high on the list, because it shouldn't be all about money necessarily. Money is a huge thing. I've only got so much money to spend on certain things, so I have to pay attention to that, just like these projects. And so design, bid, build, good for large designs. You want to take your time. I am a huge proponent of taking time up in the front so you spend less time on the back end. Design, build, these are fast-paced schedule projects. So if you are running into schedule problems, you want to get your project moving, got to complete it by a certain date. You want a design build approach. They have knowledge of construction costs, so that's a known entity. As you walk through that process, your risk is entirely on the DB. So risk is a big piece of this design build puzzle, and it's quite a nice position for the owner to be in, because at the end of the day, I have one finger, I point it right at you, and that's it. Typically, there are actually less claims with that single entity team because people aren't arguing like they may argue when you have an engineer and a contractor and you have some different entities. What they have found is there are less claims when you do design build, and I don't have the exact number. I can't remember what that is, but there are less claims with that design build is what they're seeing. And there's the word continuity again. You have continuity of staff and people. There are issues that can arise, and there's some ways to mitigate it. So this is my first bridge design I did. Pretty proud of that. It almost worked. Just kidding, of course. I don't do bridge design. Design, bid, build. You can have confusion with DCNs. So there might be a change that needs to take place. So the designer issues a DCN to change their contract, to change the contract that the GC is under. There could be confusion with these. They add up. We're on DCN number. We start with 1 and we end up, we got 20 DCNs. That's a problem. That's how you mitigate it. You try to avoid a myriad of DCNs. You really want to limit your changes that you're doing once things are starting to be built. Ownership of the work split. Again, I talked about that before. Instrumentation is one of the big headaches that we have. The contractor didn't pick up that these instruments belong to this vendor and these instruments belong to the system integrator. Loss of continuity, that's just a problem that you can develop or you can mitigate. I'm sorry, you can mitigate through communication. Really, and I was going to put it on the slide. If you communicate, that's the silver bullet. Communication will mitigate most of these issues. Integrators are unfamiliar with hardware and software, and that's a problem. When you specify certain products and they're not familiar with them, that can be a problem. So you want to make sure you vet through your and properly spec out what people are required to know. In the design build, the original contract may be old, unclear to the entire team. That's a problem. Really what you should do is make sure all the major team members read the contract. And before things get started, make sure the contract is up to date. Budget issues with design build, they can start running into budget issues and all of a sudden they're using the wrong materials because they're cutting corners. You don't want that to happen, so you just have to oversee properly design builders. And of course, deviations during construction, that's a major problem. Here's just a couple real quick ones. Lessons learned from me to you. Never bypass testing in the factory. Factory testing, I've seen it. We've done it. It's never turned out well. Schedule. Why don't we just bypass the testing? We'll make sure it works in the field. Sure you will. It never works, and it costs you time in the field. Always do testing in the factory. Look at it, touch it, feel it, make sure it works before you go to the field. Never bypass that testing. And one last one is last minute major changes. Never, ever do major changes at the last minute unless you want to spend some money and do it right. I have had horrendous experiences trying to marry up two different controller manufacturers after we had completed a design and it went out to bid and it was awarded. This was a design bid build. And then they wanted to make a major change to the controller and it did not work out well for anybody. So these are just major things that you want to avoid at all costs. So that's all I've got. Just wanted to thank you for having me. And I guess we'll go to questions, Dave.
Great. Thanks very much, Dave. Your timing was just absolutely perfect.
Excellent.
So, yeah, we do have a few questions in here. First up is, have you ever seen which had standards surrounding the user experience? And I think what they're saying here is they're wondering whether or not you've ever seen something where they define the UI layout or the page layout. And you kind of alluded to that a little bit, that it's difficult to do.
Yeah.
I guess maybe what's the best example you've seen of somebody defining how the UI should be designed?
Yeah, that's a great question. And it is obviously a very difficult one. And so I'll answer it on both sides of the fence. When I do a design bid build, I really like to, I'm a people person anyway, but I love to sit down with the right people, operations staff in particular, that are actually going to be working on the system. And we do that. You have to have that in your scope of work for the engineer, whoever the engineer is going to be. They have to have a workshop with the operations staff. So it also works in design build. And I just have noticed in the design build, I know the people up front better, and there's just a different type of relationship and different things going on. But it's all about sitting down with the right people, operations staff that are going to be using the product, along with their superiors, and really walk through how they want this thing to be laid out. Because as I said before, they have to stare at this thing for their job, and this thing has to work for them. So it is really the heartbeat of this whole thing. Even in VT SCADA software, that's what you guys are all about, and it's a very good software package, and it has a lot of options for symbols. So we usually go through the symbol libraries. The approach: is it high performance? Is it 3D? Is it standard 2D? And then we work through I like to work through each screen, but we develop standards. When I do a design bid build, it's hard to get all of those standards in text properly in a specification. So that's just the difficulty of that. So if I'm a design builder, I sit with them, I develop the screens, we look at the screens, I redevelop the screens, and really when you get to the factory test, what I like to say to owners is provide any feedback that you possibly can come up with, because this is really your last shot at it, because once it gets in the field, it's very difficult.
Right. Yeah, no, that's great. And to that, there are things like ISA 101, but it's very, very much a sort of a high-level guideline. It really, if you took 5 different people and told them all to design your system to ISA 101, you'd get 5 very different looking systems. One of them probably much better than the others. So they say
and to that point, that's a good point, because there, ISA. I'm on the board at ISA down in the south here, and we have developed a lot of standards at ISA 18, and some of the different ones that apply to the HMI product. We can put that in there, but I've done way too many of these projects where you put it in there in your spec, follow ISA 18, follow ISA 101, and it really doesn't get done. You really can't do that, and it's not fair to the contractors either. So
right. Yeah. So yeah, no, that's. I think there's some really, really good design concepts in ISA 101, which I think ISA 18 is sort of a reference of, or sorry, ISA 18.2
yes,
is referenced in ISA 101.
Right.
But yeah, like I say, there's some great stuff in there, and but like I say, it's definitely does not define your system. It just sort of basically says that you're looking for something that's closer to the high performance than the 3D. But even then, you could make a system in using 3D graphics that uses things like color saturations and other things to get more of an ISA 101 type feel. So
right, we've actually
say
gone
if you really want to have a certain look and feel, I guess my recommendation would be is don't get totally caught up that everything has to be sticks and gray, if that's not really what you want. So you can get a pretty high performing system using different graphic standards, but you do have to define exactly what you're looking for.
Yeah, it's a tough one. We've actually gone away from playing that game of the standards up in the front end of our spec and being more specific about what we're asking for from the contractors. So we've actually gone away from that in our spec.
Right. Yeah, you almost want to give them a survey that has 3 different looks and say, click on, pick the look that you would like the most, and then circle one and say, okay, we'll design, to look more like this. Or but to get a real high performing system, you do need to understand even the functioning of the system. If there's pumps that are all running at the same time, then you may want to group things like the amperage for each pump into one thing rather than having the pumps individually, so that if one of the pumps is running at a lower amperage than the others, then you know that maybe it's got some cavitation or something. So anyway, moving on to the next question here. We've got, why is it not a good idea for the engineer to contract with the client to provide programming software? Or sorry, programming services.
Why is it not a good idea?
So I think in one of your slides there, you sort of alluded, or I think it was when you were speaking to one of the slides here, you sort of alluded that you've done it, but sometimes you don't do it because it may or may not be a good idea.
That's right. That's true. I did say that. So sometimes it's not good because of, like, for instance, we have locations all over the country. Sometimes we're not located in a good spot where we can provide those services and provide them well. Or sometimes it's a specific application where I know that my staff in that locale is just not suited for that project. I don't have enough staff. I have staff that are not trained on a product, etc. So those are really the times when we just don't do it. I really look carefully before we approach a client and offer that service. And like I said, we have done that many times, but it really, most of the time we just don't do it because it just isn't quite the right fit. And And in our firm, we like to make sure that we're not stepping into an arena that's going to get us in trouble with our clients, because it's much more important that we're getting our clients to stay with us on the engineering side. Programming services, it's not a huge chunk of what we do at CDM Smith, so we're just very careful from that perspective.
Right. Okay. Thanks. So there's next question here. So the question is, how is design build different from an EPC contract?
Okay. Well, so EPC, that's engineering, procurement, construction, and those are different kinds of contractors, really. By definition, they are. It's kind of a lump sum, turnkey type contract, and so I marry them up. I talked about all the different ways, all the different methodologies that we have, and then you have this amalgam. So you have a CMAR. Well, EPC is one of those. CMAR is connected more closely with the design, bid, build type of approach, where a turnkey, this turnkey type contract, EPC type contract is they're really responsible to perform construction, commissioning, startup, and really take over a plant.
Cool. And I've just got one more question here. So I'm going to grab the screen from you just so that anybody who's on here can see where the question thing is if they're just coming in. So you should, in your Zoom console there, have a little Q&A button. If you have any questions, then feel free to type them in there. And we're just going to be closing things up before long. So type them in right now. But Dave, for the last question that I have right now is, do you find your design build clients are often unhappy with lack of control on the details due to specter of change orders?
So, yeah, the change order process, I guess. So that is, I've tried to focus on the automation side of things, and we get into some of these other things. I'm a little outside my swing zone, but
right.
With the change order process in a design build, it's a very fine line that you have to walk, because you want, this design is developed so quickly that it's very difficult to come up with extra money to implement new changes. So really, even on the design bid build side, the changes that occur, there are monies typically that an owner will have because they know these changes are coming. But the changes that occur, they really want, these have to be major changes in a design build, because the design builder is pretty much responsible for that contract. And that's why when I spoke about that, I try to make it very clear that an owner needs to spend a lot of time on that contract, because that's going to be the contract to ride through the entire process. So I'm not sure if that answered the question, but.
Right, yeah, and Jeff did note in after the fact that also part of your response on EPC also helped with that.
Oh, good. Okay, as I said, I'm not really an expert in certain approaches to these, but I've done a lot of these over the years, and I do have experience, especially obviously in the automation realm.
Right, and you're slightly unique in that you've worked as a system integrator and as a consulting engineer.
Which is why I like to say to the integrators, I feel your pain. been there, done that. So I have a soft spot in my heart for all the people doing the work. But really, it's a lot of fun meeting all the different people on the owner side and the contractor side.
Right. Yes, I think being a level above some of the system integrators, we all get a little bit jealous of some of the hands-on stuff and some of the other things that they get to actually take sort of more more start to finish on some of these projects.
I used to say I'd ride in on the white horse because I could do all of that stuff. I can't do that stuff anymore.
Right.
So I rely on the smart people coming up behind me.
Yeah. No, that's great. Yeah, so that's the end of the questions that I have for you today. Dave, you've joined us on all kinds of different things. We see you oftentimes at BD SCADA Fest and at a lot of stuff. So I just wanted to thank you for all the time that you put into helping us and helping to educate our customers to make kind of better decisions, I guess, as they work through their systems. So again, we really appreciate all the time. We know you're quite busy.
Thanks much. Yep, you have a great product, and it's a fun team over there. So
Cool.
thank you.
Yeah, and as you noted with Houston, I've noted it before, but that was a real, for us. Like I wasn't directly involved, anything to do with the sort of Houston RFP or anything like that. But when it came to that, it was one of those things that you see so much effort going into picking the right project with Houston or picking the right software with Houston that. For us, that was it kind of solidified, even though I'm talking to different people in a different area, it really solidified that, when we go in and we talk to our customers and we talk about the different features we have and what makes them different, that we say redundancy isn't redundancy. It's not a checkbox. There's different levels of complexity and different levels of, integration and how it works. So, yeah, when we get through that, it's really nice seeing somebody like yourselves on that project kind of picking us and putting such an effort into it so that we can say, yes, we do feel very confident that that what we're saying, really is true and that we are sort of leading in these different areas that really should be critical, even though, sometimes they don't quite come across that way when you look at them on the specs. It's easier to sort of check that box and say compliant, but
Right. Right. And that's a progressive design build project. So that's even more interesting. But same thing holds true, that continuity and that teaming arrangement that you have. And I'll tell you, the HMI is a huge deal for a project this size and this complicated to make sure we have the right team on that project. And you guys won it and are in it, and we're grateful you're in it.
Right. Yeah. No, we really appreciate that. And we appreciate all the time that you spend working with us and also our customers. So thanks very much for that. I appreciate you joining us today. And I'm sure we'll be chatting in the future. Hopefully we'll see you again at another one of these automation villages.
Absolutely. Thanks for having me. Thanks, everybody.
Thanks again. So that concludes things for today. So I want to, of course, thank all of our audience, because without you guys, we wouldn't have a reason to give these presentations. So we really enjoy doing it. I learned a lot at these things, and I hope that you do as well. And like I say, if you have any questions or anything, please reach out to us. And if you want to reach out to one of the presenters, but you didn't get their contact information, let us know, and we'll make sure that we help you guys get in touch. So thanks again, everybody. Have a fantastic day, and be sure to join us on July 16th for our next Automation Village virtual trade show. That's where we usually do about a dozen. I think this one in July is going to be a little shorter. We're looking at maybe a 1-hour show. And we just have sort of bits and pieces of content that are at a little bit higher level than what we did today. And we'll run through so you get all kinds of ideas, all kinds of things to think about, and see some of the latest and greatest technologies in different areas. So thanks very much. We really appreciate everybody joining us today.